बिस्मिल्लाहिर्रहमानिर्रहीम। रब्बी ज़िदनी इल्मा। ऐ मेरे रब मेरे इल्म में इजाफ़ा फरमा, आमीन। अस्सलाम वालेकुम क्लास, आई एम योर फिज़िक्स टीचर इरम। वी आर स्टडिंग यूनिट नंबर 11 ज्योमेट्रिकल ऑप्टिक्स. टुडे आवर टॉपिक इज़ refraction of light. Earlier we have discussed about the reflection of light. That was a phenomenon that the light obeys. Before going toward the refraction of light, let's recall what was reflection. Reflection can be defined as when light traveling in one medium falls on the surface of another medium, a part of it turns back in the same medium. This is called reflection of light. Here we are using a term medium. You are familiar with this term as we have used it earlier in first unit while discussing the water waves. I have told you before that the medium is a substance through which the waves can travel. It can be solid, liquid or gas. So whenever the light travels from one medium and it falls on the surface of another medium, a part of it turns back in the same medium. This is called reflection of light. Let's see a picture here. In this figure you can see air is the medium as the incident ray is traveling in the air, and suppose the boundary is of the second medium, that would suppose that is water. So when this incident ray strikes the surface of water, it will reflect back into the air again. Here the laws of reflection are also obeyed. The angle of incidence is shown here and the angle of reflection is also shown here. Both of them are equal because the light obeys the laws of reflection. Here you can also see that in definition we have used the term that a part of it turns back in the same medium. It means not all of the light which is traveling in the air is turning back into the air again. Some of it is reflected in the air. So what will happen to the other part of the light ray? Let's see. In this picture you can see the other part which is refracted into the water. It means we can say that reflection and refraction of light occurs at the same time. So we can say that when the light ray is traveling in one medium and it strikes to the surface of another medium, a part of it is reflected back into the same medium, that is called reflection, and the other part which goes into the second medium, which penetrates or absorbs into the second medium, it is called that part is refracted. So let's see what is meant by the refraction of light. What will happen to the part of light which goes into the second medium, which is refracted actually. Here is the refraction of light. We can define the refraction of light as the process of bending of light as it passes from one medium to another medium is called refraction of light. Now the part of light which goes into the second medium, which passes through from the one medium to the second medium, what will happen to that light, to that part of light? It will bend. So refraction is actually the bending of light. You can see the figure. Here you can see a glass and the air is here. Let's say this is the air, first medium, and glass is the second medium. The incident ray is present in air. This is the direction of incident ray. It is striking at the point of incidence with the surface of glass. A part of it will reflect obeying the laws of reflection and the other part will pass from the glass. Now you can see this is the actual path of the light ray. The actual path of the incident ray should be like this, but what is happening here? It is bent towards the normal. It is actually bent towards normal. Hence we can say that the refraction is actually the bending of light. It can be either towards the normal or away from the normal, depending upon the type of medium. So let's see how this bending occurs in different mediums. In denser medium, the ray of light bends towards the normal, and in rare medium, the ray of light bends away from the normal. Here we are using the terms denser and rare. What is meant by denser? Denser, from the word you can guess that the denser means a medium with high density, and the word rare means a medium with less density. From the figure you can see that air is a rare medium and glass is a denser medium. Why? Because glass is a solid, it is more dense as compared to air. So air is a rare medium whereas glass is a denser medium. So we can see that as the light ray enters from rare medium to denser medium, for example from air to glass, it will bend towards the normal, and when it leaves the glass, here you can see this ray is leaving the glass. It can also be said as emergent ray because it is now emerging out from the glass. Here the first medium is glass and second medium is again air. So the light ray is incident from denser medium and it is refracted in the rare medium. Here you can see that this is the angle of refraction, which is showing that it is greater than the angle of incidence. Let's take just these two rays. This is the normal, this will be the angle of incidence, and this is the angle of refraction, because now the light ray is incident from glass and it is refracted. It is now again passing from air. The incident ray is now, here is the incident ray in this case, and this is the emergent ray. So you can see that whenever the light travels from denser to rare medium, it is bending away from the normal. One thing more we can conclude from these 2 points is that when the light enters from denser to rare medium, the angle of incidence will be greater than angle of refraction because the light ray is bending towards the normal. And when this light ray is incident in rare, is passing from denser to rare medium, the angle of diffraction will be greater than angle of incidence. Why? Because whenever the light that was incident from denser medium is refracted in the rare medium, it is bended away from the normal, so that the angle of refraction is greater than the angle of incidence here. That was the refraction of light. And you have to remember that reflection and refraction occur at the same time. In reflection, the angle of incidence was equal to angle of reflection, but in refraction, due to the bending, both of these are not equal. So some laws, here are the laws of refraction. Let's see a video. From this video you can easily see that the reflection and refraction is taking place at the same time. Here two mediums are shown. Let's take first medium as air and second medium as glass. So what will happen? Let's see. The ray of light is incident in the air and it is reflected and refracted at the same time. The laws of reflection are obeyed here, and as the light is passing from air and entering into the glass, it is bended towards the normal. So this is the refraction of light. Now here are the laws of refraction. The light ray obeys the laws of refraction. First law is the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. As you can see, the incident ray, the refracted ray and the normal at the point of incidence means the point of incidence is that where the incident ray is striking the surface of second medium. All of these are lying on the same plane. They are on xy plane. Second law is the ratio of sine of angle of incidence, which is represented by I, to the sine of angle of refraction, which is represented by R, is always equal to a constant. That is, we can write it as sine I divided by sine R equals to constant, which is represented by n. This n is called refractive index of any medium. The second law is the ratio of sine of angle of incidence. Ratio means the division. So sine I divided by sine R. Here R is for angle of refraction. In reflection, we have also represented the angle of reflection by R, and in this case we are representing the angle of refraction by R. But you can easily recognize that whether it is angle of reflection or it is angle of refraction by the ray diagram. You can easily judge whether it is for reflection or refraction. So for refraction, the second law is this ratio of sine of angle of incidence, and the sine of angle of refraction is always a constant quantity, which is called refractive index of a medium. Here is the formula. You can write it as sine I divided by sine R equals to n. It is also called Snell's law. The second law of refraction is called Snell's law. There can a question can be there that defines Snell's law. So then you have to write only the second law. Keep it in mind that the second law of refraction is called Snell's law, as it was given by Snell's. That were the laws of refraction. Next are the examples of refraction of light. You have seen some of these examples in your everyday life. Let's see. Here is a cup of water. A pencil is placed in the water as two mediums are here, air and water, denser medium and the rare medium. Air is the rare medium and water is the denser medium. And you can see the bending of pencil, which is actually due to the bending of light rays coming from the denser medium. The depth of this pencil appears to be different than its actual depth. Here you can see a glass slab present in the path of a light ray. Suppose this is a laser beam passing from air. A glass slab is placed in its path. You can easily see that when light ray passes from the mirror, from the glass, it is bended towards the normal, and when it emerges out from the glass, it is bended away from the normal. Here is another example. You can see the two mediums, air and water. A normal is drawn. The depth of fish is different due to the difference in mediums, difference of density in the two mediums. The actual position of fish is different from its apparent position. That is due to the refraction of light rays coming from the water. Now the speed of light in a medium. So here a question can be asked that why this bending occurs in the different mediums. Because the speed of light is different in different mediums. That's why the bending occurs. Here a table is shown. You can see that the speed of light is given in kilometer per second. The air in air the speed of light is 3 into 10 raised power 8 meter per second. It is a constant quantity and you are familiar with this. Ice, the speed of light in ice is given: liquid water, vegetable oil, glass, ruby and diamond. And the index of refraction is also given. Index of refraction is the property of any medium and it depends upon the density of that medium, that how dense or how uh, mm, mm, more dense or less dense the medium is. So you can see that where the speed of light in air is maximum and the refractive index of air is minimum, then from air to diamond you can see that the speed of light is decreasing but the refractive index of these mediums is increasing. It means the in the mediums of with high refractive index the speed of light is decreased. It means the speed of light in air is maximum and the index of refraction of air is minimum, and when by the increase of refractive index of any medium the speed of light is decreased. How we can there is a relationship between the speed of light and the refractive index. Let's see what is that relation. Refractive index is defined as the refractive index n. N is a symbol for refractive index of a medium. It is the ratio of speed of light c in air to the speed of light v in the medium. Here both of these are speeds, so we have taken the speed of light as c in air and the speed of light in any medium through which the light is passing, and the medium of which we have to find out the refractive index. That medium, the speed of light in that medium is represented by v. The formula, the relationship between these quantities is n equals to cv, means that the refractive index of any medium is actually the ratio between the speed of light in air and the speed of light in any medium. Here you can see that inverse relation is there, as c is a constant quantity. It is a fixed quantity, that is 3 into 10 raised power 8 meter per second. So n and v are inversely related. Whenever the refractive index is higher, the speed of light will be lesser in that medium. And if the speed of light inversely, we can or vice versa, we can say it like this, that the speed of light is greater in the mediums with lesser refractive index. N equals to cv represents, n is the refractive index, c is the speed of light in vacuum or air, and v is the speed of light in any medium through which the light will pass, where the speed of light in air or vacuum represented by c is a fixed quantity, is a constant quantity. It is 3 into 10 raised power 8 meter per second. So that was all about the refraction and the refractive index and the speed of light in different mediums. Now it's your homework. First question is, you have to answer this question: why does the position of fish inside water seem to be at less depth than that of its actual position? You have to explain it in 2 to 3 lines. Second question, you have to answer: describe why the frequency of light do not change during refraction. Now you are familiar with the wave equation, v equals to f lambda. As the speed is changing, I have told you that speed of light is different in different mediums, so the wavelength will also change, but the frequency does not change. Why? You have to tell why the frequency of the light do not change during refraction. Third is, guess whether the bending of light be more or less for a medium with high refractive index. You have to tell that if a medium is having high refractive index, how the light will bend. Whether it will bend more or less in a medium that will have a higher refractive index. Now your next task is, you have to Do the practice of figure 12.8 and example 12.3 on sheets, as they are related with our today's topic. And in case of any problem, you can ask anything anytime. Thank you.